Hi, my name is Yap Zhan Quan, and my student ID is 0372345, and I'm part of Group 4 of Section 8, and now I'll be explaining my part in the assignment. So this this is an emission class. It's mainly used for storing and managing the total emission data, which is declared as a double type here. It will be used throughout the assignment, and you will see it later. So in this class, my electricity emission module is initialized using the scanner method, and then so it will start by calculate the electricity emission, and then the system will then prompt the user to input their data type, like what's your country's income level, and then the user have to input it based on the number selected here, 1 for high, 2 for upper middle, 3 for lower middle, and then if it's not in integer of 1 to 4, system will print out invalid choice. Please restart, enter a number between 1 and 4. And then user have to input their country name, monthly electricity usage. And then based on this, the system will use the get emission factor, and then from the txt file also, from this txt file here, the emission factors, and then the income level of their country. And then based on these values, the system will then calculate the monthly usage of the total emission from the monthly total emission based on the monthly usage in kWh times the emission factor. It can also calculate the yearly factor, the yearly total emissions, by taking the monthly usage times 12. And then so how does it read from the txt file? It reads from the txt file through here. We're using the try catch method, and then so there will be two files, one for the country and their income groups, and then one for the income level and the emission factors. So this is the country txt file, which I'll be showing here. This will contain the country names and their average per capita usage, monthly per capita usage yearly per capita usage of the electricity of their citizens. And then moving on to the other features, which is comparing with the country's average. After calculating the user's total emissions, the system will then compare it with their country's average, which is obtained from World Bank data also. So if the difference is greater than 0, using the math.round difference method, the system will print out your system will tell them that you have used more than it. If it's less than, the system will tell. If it's equal, the system will tell also. And then based on whether or not it's more than the average, the system will give advices, recommendation, like because your usage is above your country's average per capita, you can consider switching your LED lighting and unplugging devices to reduce phantom load. And then that's the other codes. There's also a monthly emissions here. And then there's a suggestion for offsets, which is like when the users see their total emissions, the system can give suggestion like, let's say you have 1,000 emissions of kg of carbon dioxide, System will then ask you to plant about amount of trees, which will be calculated, and then to offset your monthly emission. Or you can donate to your preferred trusted sustainability organization for them to help you plant the trees instead. So this is basically how my module works.